Welcome. In this lecture, we will see the linearity property of Fourier transform. So, like the linear property in vector space, the same thing we will apply here and we will see the formula, what will be the formula. So, first we will just discuss what is a linear property in vector space. So, if we have a linear transformation T, okay, in a vector space, okay, V, okay, then how we have to define the linear property? So, T of alpha V plus beta W equal to alpha TV plus beta TW. Okay, so where V and W are vectors in vector space V, capital V, and alpha, beta are scalars. So this is the linear property for vector space. Now similar technique here also will apply, because here we have transformation. So transformation, operator, function, functional, all are similar, okay, in nature. If we see the linear property, so what will be the linear property in the context of Fourier transformation, that we have to see. So let f and g be two functions which have Fourier cosine and sine transforms. So for any two arbitrary constants A and B, what will be the linear property? So linear property will be FC, means Fourier cosine transform of AF plus BG equal to A Fourier cosine transform of F plus B Fourier cosine transform of G. Okay, this one property. Next, for sine, what will happen? So Fourier sine transform of AF plus BG will be A Fourier sine transform of F plus B Fourier sine transform of G. Okay, so these are 1 and 2 relations. Now we will prove how we will get this relation. So first one we will prove. So left side we have what? FC of AF plus BG. So what is that? So if we write in expand form, so it will be square root of 2 by pi integration from 0 to infinity AF plus BG into cos WX dx. This is the formula. Only inside here, means in place of function f, we are applying AF plus BG, because we have to find AF plus BG. We have to find the Fourier cosine of AF plus BG. So now if we simplify, what will happen? The first one, so it will be square root of 2 by pi integration from 0 to infinity AF cos WX dx plus integration 0 to infinity BG cos WX dx. So this we can write. Yes or no? Now if we split it, so what will happen? Square root of 2 by pi, okay, A will be taken outside for this first integral. So 0 to infinity f cos WX dx plus square root of 2 by pi, B will take common from the second integral. So then integration from 0 to infinity g cos wx dx. So like that. So what is this? So if you see this relation, okay, so this is what? This is nothing but Fourier cosine transform of the function f. Similarly, this one is what? Fourier cosine transform of g. So what we can write? This a into 2 by pi times 0 to infinity f cos wx dx plus b square root 2 by pi 0 to infinity g cos wx dx. So this total one is what? A into fc of f plus the second one b into fc of g. So this is our RHS, and now it is proved. So first relation is proved. Similarly, second relation also we can prove by applying the Fourier sine transform. So here the change will be here sin wx. In place of cos wx there will be sin wx, and the proof will be in similar way. If we proceed, then RHS will get. So LHS equal to RHS. So second relation is proved. In that way we can get the linear property. So next we will see some application of this linear properties. Okay, this is very beautiful property which will be applied in various problems.